The program here is going to be what's called a counter. The Allen Bradley software, the counter itself comes from the tabs right over here that says counter and timer. You got different types. You have time on, time off, retentive time, we'll get into those later. You have count up, count down, and you have reset. Now what we're getting into is the file structure. If I open into the data files and we go into the counter files and I open up the counter file itself, and what we have here are different counters. Now every one of these counters will use 3 16-bit words, 3 16-bit binary groups. It's one binary group that'll operate the accumulator, one binary group or 16-bit group will operate the preset, and the third 16-bit group is going to operate the control points. Now this timer's got several control points. I could use what's called count up. It's either going to be 0 or 1. Count down, done bit, overcount, undercount, under accumulate. In reality, we can use every one of these points as a control point for the counters, and we will do so. Now looking on the program, this first line right here is nothing more than a standard start-stop station. The stop button, start button, turns on an output, output latches on, and then the output itself is going to be used as a master to turn the things up on and off. Now here we got a counter that counts up. Here we have a counter that counts down. So we can actually count up and down at the same time, but we'll get to that here in a minute. Once that counter right here, count up counter, counter number C50, that's 3 16-bit words, the preset is going to count to 10. The accumulator is going to be the real-time count. Now next line down, we have a countdown counter. C5:1. This counter counts down. The preset is -10. The accumulator is 0. Well, the count up counter counts positive numbers and it turns the done bit on. The countdown counter counts negative numbers, turns the done bit off. An example on how some of these work is on line 3, we're using counter 50. When that counter reaches its preset of 10, the done bit turns on, turning on the output. But then right here we can also use counter C51. When it reaches its done bit, its preset, it's going to turn the done bit off. Now counters are going to require a reset. We can automatically reset them with process, or reset them manually. But without a reset, it'll continue to count regardless. Now if I go online with this counter, here we're online, we're active. Let me go ahead and start this up. My stop button is now closed. I push the start button, the system's on, it's armed, it's activated. But the counter doesn't do anything. It won't do anything at all, it'll just sit there. It's going to wait for the instructions to count. So as I give it the instruction to count, as that bit, count up bit right there, input 04 changes from 0 to 1, the counter goes up by 1. But that's all it's going to do. It has to have a transition from 0 to 1 to make the count. So every time I activate this input, that counter will count. It's counting upwards for every time that bit is activated. Once it reaches the preset, the done bit turns on, but yet it continues to count. So the counter will count indefinitely. It'll count forever until it's told to stop and reset. Now the countdown counter does the same thing. As I activate the bit, it now counts negative numbers. Okay, it turns the done bit off. Once it reaches the 10, the done bit's not off, it has to go past that negative 10. And the done bit turns off. And again, it keeps counting. Now, the counter's got to be reset. So as I hit the reset button on the bottom, it resets the counter. Resets the counter back to 0. So now that the counter is reset, the done bit on the count up counter turns off, the done bit on the countdown counter turns on. So the counters themselves will count. Now I could use the accumulator as a control point. I can use the done bits. I could use any of these points. So if I bring up these files, I could use count up or count down. These will activate anytime it goes from 0 to 1, it activates. The done bit we're using. Now overcount. If I'm counting negative numbers and the negative numbers complete the cycle and change to positive, that bit turns to a 1. Undercount. If I'm counting positive numbers and when it reaches the cycle it turns to negative, this bit turns to a 1. The accumulator misses a step, this bit turns to a 1. So we can use every one of these as controls. Most commonly you use an accumulator and done bits. Now, go offline. There's other points to this counter too that we can use. I'm going to change this counter from C51 to C50. Now the general rule is you can only have one output of any address on one line, but here we have two counters with the same address. This is one of the exceptions to the rule. One counter counts up, one counter counts down. They are both going to have the same accumulator. We can put the same preset in. They're going to have the same count. Now if I verify this wrong, there's no errors. No errors. I go to download this circuit. All I do is download it. Save changes. Yes, I have to save changes to download. Proceed with download. Place the processor in run mode. This is going to be software actuated. And as I write this file, it erases everything in the past memory. I have a channel configuration here. This is communications. If I apply, I got to restart everything. So I do not apply and I maintain my standard communications. I go back to run mode and I go online. Well, here we got the same counter. Now as I push the input to make the counter go up, well, first we got to start it. And if I push that input to make that counter go up, look at the accumulator on both counters. One counts up, one counts down. But now the counter right there went into the negative preset. So the countdown counter is going to be the dominant counter. Okay, and the done bit is going to act like a countdown counter. But both right there will activate at the same time. With two separate inputs, I can count up with one input, down with the other input. And once I reach the preset of 10, again it turns the done bit off. So I can have bits that count up, bits that count down, counters count up and down at the same time. Counters are pretty frequent in all types of programming.